Good morning, everyone, dear authors and invited guests. Welcome to the technical session 7D. I, Meghna Mathur, and am I am Meghna Mathur, and the session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on Information and Communication Technology for Competitive Strategies ICTCS 2025, Jaipur, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held on 15th December 2025 in Jaipur, India, and the virtual event is being held through Zoom on 16th and 17th December 2025. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for the conclusion and question and answer. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any request or query or an update, then you can write to me in the chat box. Just before we start the session, I would like you to introduce you all to the chair of this session, Dr. Lokendra Singh Umrao. Sir is an associate professor, Department of Computer Science and Engineering, Madan Mohan Malviya University of Technology, Gorakhpur, India. With over 11 years of teaching experience, his specialization lies in algorithms and high performance computing. His research interests include blockchain technology, Internet of Things, big data analysis, and parallel computing, contributing significantly to advancements in these domains. So, welcome. Now, we will start with the presentations. Our first author is P. Kiran May, and the title of their paper is A Comparative Analysis of Smart Pill Dispensers Innovations and Challenges.
Good morning, everyone. Can I present my screen now?
Yes, sir, please.
Is my screen visible?
Yes, it is.
Yeah, thank you. So, good morning, everyone. My name is Meka Viraj. I'm co-author of this paper. Today, I'll be presenting our paper titled Analyzing the Cyber Threat Landscape and a Comparative Ethical Study of Modern Phishing Toolkits. This work focuses on understanding how modern phishing attacks are created and using open source toolkits, and more importantly, how we can study them ethically to improve cyber defense mechanism. The motivation behind this paper is that phishing remains one of the most effective cyber attacks, not because of the technical exploits, but because they target human behavior. Phishing continues to be one of the most persistent and rapidly evolving cyber threats. In this paper, we perform a comparative and ethical analysis of three widely used open source phishing toolkits: Zfisher, NextFisher, and Rubik's Fish. We compare them based on factors such as usability, automation level, customization, and stealth capabilities. All analysis is conducted strictly within an isolated defense search environment, ensuring ethical compliance and zero real world harm. We also propose structure quantitative metrics like credential submission rate (CSR) and detection evasion rate score (DES), which can be used in further experimental evaluation. Overall, this paper highlights how phishing tools are becoming more sophisticated and why defenders must adopt proactive, research driven defense strategies. Phishing remains the most successful social engineering attacks globally. Unlike traditional cyber attacks that exploit for software vulnerabilities, phishing exploits human trust. Today, attackers no longer need a deep technical skills. They rely on automated phishing toolkits that can generate realistic fake login pages within minutes. These toolkits significantly lower the skill barrier required to launch phishing campaigns. Understanding how these tools work from defense perspective helps security professionals design better detection and mitigation strategies. In this study, we ethically analyze Zfisher, NextFisher, and Rubik Fish, ensuring the research focuses strictly on defensive, not offensive misuse. All research is conducted inside an isolated network testbed INT, meaning no real users, no real internet, and no production system are involved. The main objectives of the research are first, to compare the functionality of the modern open source phishing toolkits. Second, to examine their ease of deployment and operational sophistication. Third, to evaluate their customization and stealth capabilities. Fourth, to design ethical and measurable metrics for evaluating these tools. And finally, to analyze the defensive implication and prepare groundwork for future data driven experiments. From the literature survey, we observe that phishing has evolved significantly over time. Early phishing attacks involved simple manually crafted emails. Over time, our automation became the dominant trend. Tools like Selfish influenced modern frameworks by introducing reusable templates. Zfisher gained popularity due to its simplicity and high template availability. NextFisher improved on this by adding URL spoofing and better credential capture mechanisms. Rubik Fish presents the current trend, focusing on automation and stealth. When we look at existing and trending methods, we see phishing as a service. Methods, uh, platforms tunneling service for stealth, session token hijacking, and even AI generated phishing content. These trends clearly show why traditional signature based detection is no longer sufficient. Our proposed methodology follows a strict defensive first approach. All experiments are planned inside an isolated network testbed,
Excuse me, ma'am.
ensuring ethical compliance.
Excuse me. Sorry for the interruption. Actually, ma'am called our paper Comparative Analysis of Smart Pill Dispensers Innovation and Challenges. Excuse me, ma'am.
Hello.
Sorry
Yeah.
for the interruption. Actually, you called our paper and someone presented
Yes.
their paper actually.
Yes. Just give me a minute. Mika Viraj, could you please repeat your paper title?
It is analyzing the cyber threat landscape.
Okay.
Should I continue or should I stop?
Sir, could you please stop and just give us a minute to clear this thing? And meanwhile, ma'am, Ranvita ma'am, could you please start sharing your paper?
Yeah, actually, we are a team. Himaja and I are presenting this presentation. She will
Okay.
start the presentation, ma'am.
Sure, sure. Thank you, ma'am.
Thank
Good morning, ma'am. Good morning, respected chairs, reviewers, and my fellow researchers. Today we are pleased to present a paper titled Comparative Analysis of Smart Pill Dispensers, Innovations and Challenges. This work is authored by P. Kiranmay ma'am, Venugopalachari sir, and myself Himaja, and my co-author Ranvita. Our study focuses on analyzing recent advancements in smart pill dispenser technologies and the practical challenges that limit their real world adoption. Medication adherence is a critical issue, especially for elderly patients and individuals managing chronic illnesses. In this paper, we present a comparative review of smart pill dispensers that integrate technologies such as IoT, artificial intelligence, machine learning, RFID, blockchain, and wearable systems. We evaluate these systems using 5 key parameters that are usability, energy, efficiency, cost security, and dependability. Our findings highlight important trade offs. For example, while advanced security improves trust, it often reduces ease of use, and continuous connectivity increases energy consumption. These insights help guide future designs like towards more patient-centered, secure, and scalable solutions. Medication adherence plays a vital role in achieving effective treatment outcomes. However, many patients, particularly older adults, struggle with missed doses or incorrect medication intake. Smart pill dispensers aim to address these limitations by introducing automated dispensing, real time monitoring, intelligent reminders, and caregiver supervision. With the integration of IoT, AI, and secure authentication methods, these systems represent a shift towards technology assisted healthcare management. The primary objective of this work is to provide a structured comparison of modern smart pill dispensers. Specifically, we aim to review the evolution from basic timer based systems to AI enabled dispensers, which evaluate devices based on affordability, energy consumption, usability, data protection, and regulatory considerations. We also identify gaps related to reliability and accessibility. This scope allows us to assess not only technological innovation but also real world practicality. IoT forms the foundation of many contemporary smart bill dispensers. These systems enable real-time tracking, automated alerts, and remote caregiver access. Studies such as Sharanya, which demonstrates effective mobile app integration, improving adherence monitoring. However, they also report delays caused by unstable network connectivity. Similarly, cloud-based and RFID-enabled solutions improve access control, but face challenges in rural or low connectivity environments. The key takeaway is that while IoT significantly enhances monitoring capabilities, offline support, and secure communication remains essentially for reliability. Next, artificial intelligence and machine learning are the smart dispensers from static devices to adaptive systems. The research also shows that AI driven models can analyze user behavior to personalize reminders and even predict the other non adherence patterns. For example, behavior aware reminder systems have shown improvements in adherence among elderly users. These benefits come with challenges like including the need for large training data sets, privacy protection, and interoperability with electronic health records. Addressing these concerns is a crucial for responsible AI deployment in healthcare. Now I hand over the presentation to my co-presenter, Ranvita.
Yeah. Coming to the blockchain, RFID, and accessibility. Uh, uh, Blockchain-based approaches provide tamper-proof logging and traceability, reducing risks such as fake medications and unauthorized access. RFID systems further enhance identity verification, while extensions like smart cups help confirm actual pill consumptions. At the same time, accessibility features such as voice guided interfaces improve usability for visually impaired or elderly users. The challenges lies lies in balancing strong security with simplicity and low computational overhead. And coming to the next slide, comparative analysis across technologies. Here we discuss about, based on our study, smart pill dispensers can broadly classified into four categories. IoT centric systems focusing on continuous connectivity, AI centric systems emphasizing personalization and interaction, security enhanced system using biometric and blockchain, sustainability oriented systems incorporating renewable energy. Our analysis shows that optimizing one dimension often introduces trade offs in others, highlighting the need for balanced design strategies. And next, affordability and reliability changes. Cost remains one of the strongest barriers to widespread adoption. High end dispensers offer advanced AI and IoT features, but often involve subscription fees, making them inaccessible to many users. Lower cost alternatives sacrifice automation, tracking accuracy, or reliability. Additionally, system reliability is affected by connectivity loss, sensor failures, and speech recognition limitations. Designing affordable yet dependable systems is therefore a key research priority. And uh, coming to the next one, we discuss about the sustainability and energy constraints. Continuous operations dispensers depend heavily on power availability. Battery powered systems require frequent recharging, which can be inconvenient for elderly users. Solar assisted models offer promise in rural or off grid areas but are dependent on weather conditions. Hybrid rechargeable batteries emerge as a more reliable approach for long-term sustainability. And next one, that let me discuss about the data security and private issues. Smart pill dispensers handle sensitive health data, including medication schedules and patient behavior patterns. Without strong encryption and accessibility, these systems are vulnerable to data breaches and unauthorized access. Blockchain improves data integrity and transparency but introduces computational and cost overheads. Hence, lightweight yet robust security mechanisms are essential to protect privacy privacy without compromising the performance. And next one, usability, adoption, and future design. Ultimately, user experience determine the adoption success. Elderly users prefer simple interfaces, voice guidance, clear visual cues, and minimal interaction steps. Complex dashboards or subscription models often discourage long-term use. Future design should prioritize human-centered principles, offering multilingual support, personalization, and caregiver access to improve engagement and trust. And coming to the conclusion and research contributions, to conclude, smart pill dispensers represent a significant advancement in healthcare automation by combining IoT, AI, and secure data practices. However, challenges related to affordability, reliability, sustainability, security, and usability continue to limit large scale deployments. This work contributes a structured comparative framework that highlights these trade offs and guides future research directions. Moving forward, collaboration among technologists, healthcare professionals, designers, and policymakers will be essential to develop inclusive, scalable, and patient centric solutions. And thank you for your time and attention.
Hmm. Himanja,
Yes, sir.
you have used a number of disruptive technologies like IoT, AI, blockchain.
Yes, sir.
Yeah. And you have to secure some sustainability concept also.
Yes, sir.
So I have one more suggestions. Actually, UN decide 17 SDG goals. Have you ever know the SDGs goals of UN?
Sorry, sir, I didn't get you.
Sustainable Development Goals, which is decided by the UN,
Okay.
United Nations.
Oh, yes, sir. Yes, sir.
Yeah. So you have to target one of the goals in your paper research.
Okay. Yeah, okay, sir.
Because without the SDG goals, there is no meaning of research.
Yes, sir. We will definitely look into it once.
Your work is too good because you have used disruptive technologies. They are very much useful in the near future, but you have to achieve one of the goals, which is decided by the SDGs.
Yes, sir.
Yeah, all of them fine.
Yes, sir. Thank you, sir.
Thank you. We'll move further with our presentation. Our next presentation is being presented by Shariman PC, and the paper title is AI-driven security and operational resilience, mitigating fraud in the unified payments interface UPI ecosystem.
Good morning, all of you. Dr. Shariman here, Dean of Arabic University in Oman from Muscat. And this paper was done by my students, those who did internship in India. They are the bachelor students, even they are not master students. So one of the issues we raised during my visit to India was the digital transformation or the digital revolution, what happened in India. And last 2 3 years, I was continuously monitoring that there are some frauds, I mean, some issues faced by the merchants, even the coconut tender sellers and other people, especially those who are the street sellers, even they are using the QR code for their entire operations. A wonderful revolution happened in the world, which is a model is India. Because even though when we are traveling to other part of the world, we never see this much revolution in the digital transformation. Even people, they never visit the schools. I talked to many of the street sellers. Even some of them, they never see the school. Even they don't have a school education, but they are using technology in a practical aspect. That's the researchers. It was a wonderful experience for me, and I have suggested my students, those who come for an internship in my in my factory. I have some business in India. So to make a study and the level one, year one students of a bachelor students, they did this project, I mean this research. And I am happy to present it. The aim of the presentation is to just reveal the issues what they are facing and how we can solve it. Even it's a like literature review, it is not a pure technical side we are suggesting, but we are giving a model how we can protect them from the frauds. That is the purpose. So if you are moving forward, so this is the basic idea. UPA has made a wonderful change. Even it's a wonderful platform. It is a really model for other part of the world. Even compared to USA, I feel that this digital transformation of digital payment is most or much important in India. So as I already mentioned, I don't want to take the time for this one. And this is the result. Even these are the basic introduction, which I already covered, so I can save time to cover the presentation on time. So even we are looking for the UPI scale and compared to any other digital transformation or digital payment system, UPI is it is growing fast with all aspects. And I feel proud that India is moving to the cashless economy. I don't think so. Even Gulf countries or even other foreign countries, which is already developed countries, they cannot claim this achievement. Okay, so this is as a researcher and as from computer science background, we feel so happy that we dream a day where people are not carrying cash. And that is already happened in India. But what are the issues there? What they really suffering? Are they suffering? Okay. We talked to many. We had a wonderful data collections and real time data collection. My students, they travel, this happened in Kerala. They have traveled all the parts of Kerala from different aspects to get the data. And these are the main gaps we fell here. You can see here that we call it the research gap. There are many technical issues actually. Okay. See, even though we claim that it is cashless economy, you can have it, but in many of the places, network is an issue. Assume that you are carrying, and even we face this issue, even myself. You are going somewhere, we don't, you are not carrying cash, but sometimes, you were not able to pay. This is the reality because something bank server failure. Even though it is not your fault or even not the UPS system fault. Sometimes bank server may not be working. Even Google Pay or any of the payment system which you are connected to a particular bank. And there is some merchant disputes are there. Okay, that means their ecosystem there is denial of service and everything happening. And there is a big social engineering here. That is we have to address as researchers. What is the social engineering behind it actually? So, there is a trust, psychological manipulation, and such as, it is anxiety and fear. It will affect people much. And so I know that one of the shops, they stop using the digital transformation, I mean digital technology, because they lose money and a huge amount of money in a fraud. So they are afraid. They are afraid that how we can move. And these are even though this is a small case, maybe the percentage is very less, but we have to ask researchers, we have to address these issues also. Then only research will go to the social side. As the chair mentioned about the SDGs, of course, all the research should be, and in one of the is this eradicate poverty and even trustworthy in the society. That is very important in every aspect. Okay, and even though we face that the merchant scams, in many of before that there was no sound system. Nowadays almost all the payment system is equipped with sound. That means when somebody is paying the money, even we felt it and we found that we prove it is happening in front of us. So maybe the actual amount is to be maybe 700 or even 70 rupees. Okay, maybe it is 70 0. Okay, but they pay only 17 and the system will give the pronunciation that 17 rupees paid, but the merchant, the merchant he will be very busy with other things. So okay, 17 is, it may be 70, okay, or it may be 80. So even the multiples of 10, even 10 people defraud, he will lose the entire livelihood of one day. This is always happening. Okay, even these are the social aspect of the system we have to educate. And we thought of what is the research objective. Our objective is to make how we can have a system which can integrate AI and machine learning, okay, to improve, to have at least an attempt to support the user in these aspects. So this is the study, and this one I can save time from this one. So this is the main things the application problems we in this. There is a infrastructural issues are there, technical issues are there, security is there, user experience is there. We have given importance for all these things in our research. So when it's come to the flows, you can see that the operational flow, that is a base issue. When the operational flows comes, technical failures is happening. This is one of the problem. Bank server is down, payment failure is happening, mobile freezing. This is the reality is happening in some of the operational flow. And infrastructure, see, internet is not still, but we have to feel proud that even the villages everywhere, even when we went to one shop for a study, that I think it's a very small shops. Okay, I don't think so. Their per day income will be may not be, the total sales will be maybe 3,000 rupees. That's what maybe this is I asked them, but they have Wi-Fi connection, because when we lose our Wi-Fi, they told us, and even that lady, she is illiterate. She told me that actually the browser use the Wi-Fi we have, so that way they know, but they have other issues actually. Okay, so these are the problems are there. At that time, sometimes bank is not working, so the people those are there is, I don't have money, how I can pay, and there is a clash. This is moving to the emotional side. Okay, then systematic vulnerability is there. This is leading to the seek of support of the unverified product. That means the fake customer care number, and they are calling, and it is directing. Such issues are there. So that's the outcome of this one. Is the scammers are exploiting this vacuum. You know that internet fraud and the payment fraud is the main fraud. What is that? Is even more than the theft. Okay, it is happening in all over the world. Maybe in Asian side of the system, it may be more in that aspect. So when we are moving to the security threats, we can say that the social engineering side, okay, that is a core tactic, okay, the psychological manipulation. That is the main issue, the fear and greed that is happening in one aspect. Then phishing links, fake customer calls, urgent refund, that means lot of messages. These all are still happening in this aspect. You use this one, use that pay, use this pay. People are illiterate, some of them. I mean, I'm not talking about the merchant. I'm talking about the customers also. Both are there actually. Okay. And the weak link. Okay, that is the behavioral aspect of making the user weak link. There is a security threats and they feel it emotionally. Then when it comes to the merchant fraud, the QR code swapping. Even in one situation, we understand that the QR code was different, and even the payment is going to some other accounts actually. How people are making the fool for these poor people. They are looking for their daily bread and butter. And underpayment fake alerts. Okay, the same thing example I told that instead of paying 70 rupees, they pay 17 and they feel that it is 70. Okay, so such a manipulation is happening with the purposefully. Okay, even they are not business people; they are poor people for their street sellers. And and this is the critical impact of the ecosystem. Okay, that means they lose the trust. Okay, and repeated comes. It will happen to anybody. They are afraid. Okay, how we can use it actually? That is revert to cash. In some case, in some of the users we talked to them, and some of the merchant told that no, 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 no cash. Sorry, no such a technology. We will go for cash because they are afraid because it is their experience. So as researchers, as people in the industry, I mean with IT, I mean computer science, it is also our responsibility to make sure that such systems are working very nicely to support the society. And the financial and that cost, that means direct loss of money. They are losing money. Maybe if they lose 1,000 rupees, it is like their entire savings of a day or even 2 days. That is depends actually. They are losing it actually. Then the operational hindrance is there actually, due to the lack of a manually verification transaction and even refuse to accept. UPI will say that this all technical. When we call people, this whole call center, that machines are working instead of human, and people will not call again. This is one of the problem we face. How people will call? They will get, you press 1, you press 2, you press 3, and how many press they have to, and finally they are not getting the real answer, and you wait for the customers or somebody will take the phone, and they fed up, and nobody will call again. And this is the gap. So we
Sorry
feel
to
that
interrupt, sir. This is a gentle reminder that you have 1 to 2 minutes to conclude your presentation.
thank you. So this is the way, where there is an awareness gap is there. Okay. So that means, people are there, but technology was enforced everywhere. Technology was used by radically everywhere. It is happening as I say, a revolution. But did we educate the people in that way? And that's a big question. Okay. And even this OTP and even, OTP itself is, people are sending the OTP. How much? I think society has to be very careful about, researchers has to be, we have to educate the normal people. Institution has to educate in that way. So maybe I will finish with my recommendations, and we feel that this is the recommendation. So this is the model we are proposing. The traditional rules-based systems are obsolete due to high false positive and inability to adapt to emerging fraud trends. Okay, so AI provides system, because AI can play a wonderful role here. So how we can that actually? Okay, and even AI should be, we have to integrate the power of AI to such transactions, and such users should be, they should get the awareness, and they should be alerted with powerful technologies, powerful systems, how we can support both the merchant and the people. Okay, so in the case of this suggestions, I mean, AI security, sir, that is mitigating the fraud risk. Okay, one mechanism we feel that you can see that AI learns individual spending habits, because if the individual spending habits can study, definitely there can be a trigger or there can be a support system by the technology to the people. Okay, that means regarding the frauds, then the alerts can be raised. Okay, because the flags is, that means suppose assume that there is a large payment or something happened, not from the bank. I'm talking about the UPS system. Something happened in one way or other way. If somebody is taking my machine, and even some of the payment system, there is no biometric authentication, or that is not there actually. In such case, if somebody is taking the phone and they can make the payment, okay, even without the, somebody did not set the security check. So it is happening. People are losing the money. So if immediately AI triggered with all these things actually, so we can make the support of that one. People should not, they will not lose the money. So that is the flag significance and everything is there. And the real-time scoring. you can say that we can assign a risk for the every transactions in the history, and the history can be a wonderful data to analyze and support the maybe both the payer and the receiver. Okay, so and even the social engineering, how we can make, especially for the QR code fraud and everything, we can apply the computer vision that verifies the QR code and detect image manipulation directly addressing the merchant fraud. That is one solution is there. And regarding the amount transaction, we can use NLP support with the OTP and all such kinds of frauds. I hope this will not eradicate the full system. The main way we have to educate the people in every aspect to make this movement of the world, because research means to support the poor people also. That should be our aim. Okay, so this is my conclusions. UPI made a wonderful changes in India, but at the same time, we have to think that people are losing the money because of technology, because of social media, because of social engineering. So the entire society has to put their hands together, because the people, those who are the victim, is the poor people. They are losing their lifelong earnings with such kinds of situations. So this research, our intention is to just open the eye of the society also, or the researchers also, that actually these are things happening, and we made a study. It was a literature review, and the study reveals that many people are not revealing the real problem, because they feel that it is like a social status for them. If I lose money means, people will think that I am not a good businessman and I don't know how to use technology, and they become really in stress. These are the real issues happening in India, in especially in this, our study was in Kerala, but this is all applicable to the world, as it is a common problem. Thank you. And I again, this was done by some bachelor level one students, those who are coming to the research world, and I support them. That's all. Thank you very much. Back to the chair.
Thank you very much, Dr. Simon. Such a wonderful talk about AI-driven security and how can one can use UPI ecosystems. Actually, there's number of issues because in the India, the population growth is too high. So number of illiteracy is also is there. Our technology day by day growing. As Murray law predicts, in every 1.5 years, technology doubles and changes. So it is the biggest issue in India. How can they go through the technologies?
Exactly.
Thank you.
Exactly.
Thank you very much.
Thank you, Professor. Thank you very much for your time. Thank you, the organizers.
Thank you,
I am.
sir.
Thank you. I am leaving. If there is any question, kindly send me actually, because I have another important meeting in the university. So thank you very much for the opportunity. Thank you very much.
Thank you, sir. Now, moving further, we have our next paper by author Samuel John, and the paper title is AI powered brain tumor segmentation and treatment recommendation system using mask RCNN and Gemini model integration.
Hello, ma'am, am I audible?
Yes, sir, you are.
Can I have like a few minutes? I have some issues here. Like, can I present next or something?
Okay, sir, sure.
Yeah, I present next. Thank you.
Moving forward, we have our next presentation with the paper title by author P. Kiran May, with the paper title Analyzing the Cyber Threat Landscape, a comparative and ethical study of modern phishing toolkits.
Yeah. Is my screen visible?
Just a minute, sir. Yes, your screen is visible.
Yeah, thank you. Okay, good morning, everyone. Today I'll be presenting our work titled Analyzing the Cyber Threat Landscape, a comparative and ethical study of modern phishing toolkits. The core idea behind this paper is very simple. Phishing is still one of the most successful cyber attacks today, not because systems are weak, but because humans are vulnerable. Instead of looking at phishing only from a victim's side, this paper tries to understand how attackers design phishing campaigns using modern open source tools, but strictly from an ethical and defensive research perspective. The goal is not to teach attacks, but to help defenders understand the threat landscape better. Phishing continues to be one of the most persistent and rapidly evolving cyber threats worldwide. In recent years, attackers have increasingly relied on open source phishing toolkits, which automate many steps of an attack, such as template creation, hosting, and credential capture. In this paper, we present a comparative and ethical analysis of three widely used phishing toolkits: Zfisher, NextFisher, and Rubikfish. These tools were selected because they present different levels of sophistication, from beginner friendly tools to more advanced and self focused frameworks. The comparison focus on usability, automation level, customization options, and stealth capabilities. Importantly, all analysis is conducted strictly within an isolated defensive search environment, ensuring full ethical compliance and zero real-world impact. We also propose structured quantitative metrics such as credential submission rate (CSR) and detection evasion score (DES), which can be used for future experimental evaluation. Overall, the findings highlight how phishing tools are becoming increasingly sophisticated, emphasizing the need for proactive and research driven anti phishing defensive strategies. Phishing remains the most successful social engineering attack globally. Unlike malware or network based attacks, phishing does not primarily exploit technical vulnerabilities, it exploits human psychology. Attackers take advantage of trust, urgency, fear, and familiarity. Earlier, phishing attacks were manually created and relatively easy to identify. However, today attackers use automated phishing toolkits that can generate realistic fake login pages for popular platforms like social media, email services, and cloud applications. These toolkits significantly lower the skill barrier required to launch phishing campaigns, allowing even non experts to perform attacks. Because of this, understanding how these tools work is essential for cybersecurity professionals. This study focuses on three such toolkits: Zfisher, NextFisher, and Rubikfish, and analyzes them ethically without executing real world attacks. The entire research is carried out inside an isolated network testbed, ensuring the work remains purely defensive and responsible. The insights gained can help improve phishing detection and systems and user awareness programs. The objectives of this research are clearly defined. First, we aim to compare the functionality of modern open source phishing toolkits. Second, we analyze the ease of deployment and operational sophistication, which reflects how accessible these tools are to attack. Third, we evaluate customization and stealth capabilities, which directly influence the detection difficulty. Fourth, we detect ethical and measurable evaluation metrics that allow structured comparison rather than subjective judgment. Finally, we analyze the defensive implications of these tools and lay the groundwork for future data driven and experimental research. The literature survey shows a clear evolution in phishing techniques. Early phishing attacks relied on manually crafted emails and static fake pages. Over time, automation became a key trend, reducing manual effort and increasing scalability. Tools like Shellfish played an important role in shaping modern phishing frameworks by introducing reusable templates, Zfisher emerged as a popular toolkit due to its simplicity and large number of ready-made templates. NextFisher built upon this by introducing improved URL spoofing and better credential capture mechanism. Rubikfish represents the current generation of phishing tools, focusing heavily on automation and stealth to evade detection. When we look at the existing and trending methods, we see phishing as a service platform, tunneling services for hiding attackers' infrastructure, session token hijacking, and even AI generated phishing content. These trends clearly indicate that static detection techniques like simple URL blacklists are no longer sufficient. Modern defenses must evolve towards behavioral and anti-intelligence approach. Our proposed methodology follows a strict defensive first approach. All experiments are planned and conceptualized inside an isolated network test bed, which is fully disconnected from the internet. The tools analyzed at Zfisher, NextFisher, and Rubik's Fish. No real users, production systems, or live networks are involved at any stage. The evaluation is based on factors that directly impact defensive understanding, such as setup ease, template variety, customization, stealth, and post exploitation data capture. To move beyond qualitative analysis, we define several quantitative measures. These include deployment time, which can measure how quickly a campaign can be launched, credential submission rate, which reflects how convincing the phishing page is, time to submission, which measures how user interaction speed, URL blacklisting evaluation time, which indicates stealth, and static analysis true positive rate, which reflects detection effectiveness. Together, these metrics form a structured framework for ethical evaluation. This table summarizes the key differences among the three toolkits. Zfisher is very easy to set up and suitable for beginners, but offers limited customization and low stealth. NextFisher provides a very high template variety, modern stealth, and stronger URL manipulation, making it more convincing. Rubik Fish emphasizes automation and stealth, requiring higher skill but offering better evasion capabilities. These comparisons clearly show a progress in attackers' capability from accessibility to sophistication. For defenders, these highlights the need to prepare for different attacker profiles. The slide illustrates the isolated network testbed used in our research. The attacker's system runs on Ubuntu, while the target system runs on Windows and Kali Linux. All systems are connected via private virtual network, a completely isolated from internet. This ensures that phishing phases, credential capture, and detection analysis remain fully controlled and ethical. Such an environment is essential for responsible cyber security research. Results: since the paper defines experiments but does not execute them, the results are qualitative and expectation based. Based on toolkit capabilities, Zfisher is expected to be the fastest to deploy but offers the lowest stealth. NextFisher is expected to achieve the highest credential submission rate due to its realistic templates. Rubikfish is expected to provide the longest blacklist evasion time due to its automation and stealth mechanism. These are expected outcomes based on tool design, not measured values. Overall, the results indicate that phishing tools are becoming faster, stealthier, and more difficult to detect, increasing the challenge for defenders. These diagrams illustrate the ethical evaluation workflow and the role of tunneling services. The workflow diagrams show how phishing templates are generated, deployed within the isolated testbed, interact with by simulated users, and evaluated using Defined metrics. The port forwarding diagram highlights how tunneling services can be influenced detection and evasion. From a defensive perspective, this shows why monitoring tunneling based traffic is critical. To conclude, this paper provides an ethical and structured comparison of three modern phishing tools. We observe a clear functional gradient from simple tools like Zfisher to highly automated and stealthy tools like Rubik Fish. Most modern tools significantly reduce the technical skills required by attackers, increasing risk. Defenders must therefore shift towards behavior analysis and intelligence driven detection. The the proposed metrics and methodology enable future quantitative validation. Future work includes executing these experiments and developing a machine learning based phishing detection models. These are the references that informed our work. Yeah, thank you for your
Viraj,
time.
yeah, your topic on the cybersecurity and phishing tools. So you hear about the CIA.
Uh, no, sir.
When we are talking about the cybersecurity and phishing
Phishing
attacks,
tool.
we should know the CIA.
CIA tool.
You know, confidentiality, integrity,
No,
authentication. You
no,
heard
sir.
or not? Huh.
No, sir, I'm not sure.
No, these are the basics of the cybersecurity. है ना? So first of all, you have to study the basics things, है ना? Then go for the research, right?
Yes, sir.
Yeah.
Thank you, sir. Now we'll move further. Our next presentation, the author is Swati Kumar with the paper title Blockchain Enabled Self-Healing IoT Framework for Predictive Fault Management in Aviation Systems.
Yeah. Am I audible?
Yeah.
So good morning, everyone. I am Shakti Shani S, along with my co-authors, Professor Anish Kiri and Swati Kumar from PES University. Today, we'll be presenting our work on self-healing IoT network with blockchain-enabled resilience, focusing on aircraft sensor reliability, which is a critical safety concern in modern aviation. So, in this presentation, we will cover the problem statement, our proposed solution, methodology, key results, and finally, the conclusion. So starting off with our problem statement. So modern aircraft relies heavily on large networks of flight critical sensors. The issue is that the current fault management systems are reactive and they only detect failures after the sensor has already failed. This leaves very little response time and often requires manual intervention, which is risky in aviation systems. Another major concern is logging and transparency. So the flight incident logs are usually stored in centralized systems which can be modified, lost, or compromised. So this creates challenges in post-incident audits, regulatory trust, and safety analysis.
Now I'll be talking about the abstract and scope of our project. Next slide, please. This project is going to focus on predictive aircraft sensor failure detection with a self-healing mechanism and secure event logging. We built a simulation with 10 critical aircraft sensors operating across 3 flight phases: takeoff, cruise, and landing. Sensor failures were deliberately injected, and a decision tree model was trained to detect anomalies and predict failure trends before sensors stop transmitting. So when a failure is predicted or detected, a smart contract-based self-healing mechanism immediately activates a redundant backup sensor. All failure and healing events are logged onto blockchain, ensuring auditability, transparency, and trustworthy sensor failure records. Next slide. This is our proposed solution overview. We have 6 modules, which we'll be looking into further in the next slides. This is our architecture diagram. Each one of the modules will be explained in the further slides. Next slide. So now we'll be looking into the methodology of our proposed research paper. Next. So this slide is going to explain the first module, which is the sensor data generation module. So it's going to explain how sensor data is generated in our simulation. So we have simulated 10 flight critical aircraft sensors, such as accelerometer, flutter, and fuel temperature sensors. Each sensor is going to produce data within predefined healthy ranges with added statistical noise and realistic fluctuations based on the current flight phase, takeoff, cruise, or landing. A central flight phase controller manages these phases and broadcasts a synchronized tick every second. All the sensor threads fetch the current phase, the generated phase-specific values, publish the readings, and acknowledge the tick. So this is going to ensure all the sensor data is synchronized, time-stamped, and consistent across the system. Next slide. This slide is going to explain the fault injection module of our system. So faults are manually injected after a controlled delay to mimic real-world sensor issues. So for example, we introduce bias drift or zero-G offset shift in our accelerometer and thermal runaway conditions in the fuel temperature sensor due to overheating or faulty nearby components. Once triggered, the affected sensor first degrades, then stops publishing the data abruptly, leading to complete sensor failure. So this controlled fault injection is going to allow us to observe the system behavior as it transitions from normal to degraded and finally to fault states, which is crucial for training and validating our failure detection and self-healing logic. Next.
Is my screen visible?
Yes.
So we have an anomaly detection layer, which is a reactive layer. So in this, what happens is the sensor, the system observes all the 10 sensors simultaneously and see which sensor stops publishing. And it waits for ticks of every sensor to keep publishing. And if a sensor stops publishing after a certain window of time, it thereby concludes the sensor has completely failed and then triggers a self-healing. But we also have, that is just a backup layer where our main layer mostly focus on fault prediction. So the fault prediction module operates as a proactive failure forecasting layer using a supervised machine learning approach. So real-time accelerometer data is processed in rolling windows of 5 samples from which statistically meaningful features such as the mean acceleration, RMS value, and the temporal slopes are extracted. A distant tree classifier, which is trained on labeled healthy and fault injector sensor data, classifies each window as healthy, faulty, or inconclusive. And to reduce false positive and improve robustness, the failure is confirmed only when multiple consecutive windows are predicted as faulty. As a result of our model, we saw that in a total of about 100 test samples, our system was able to correctly classify 99 of them, resulting in an overall accuracy of about 99%. And furthermore, the prediction distribution reflected a balanced, even performance, with the model correctly predicting 54 healthy sensor instances and 45 faulty sensor instances. Next, we have the self-healing.
Now we look into the self-healing module. So when a sensor failure is detected, the system is going to first check whether the predictive healing was already activating a backup sensor. So our major self-healing mechanism is to add a backup sensor in order to account for the failure in the sensor. So if the predictive healing has not already activated a backup sensor, the backup sensor is immediately activated and starts publishing data, and this activation is logged onto blockchain. In the predictive case, the model is going to anticipate an upcoming failure, logs the prediction onto the blockchain, and triggers healing via smart contract before the sensor actually fails. This is going to ensure that there is uninterrupted data flow, transparent event logging, and autonomous recovery across all flight phases until the simulation ends. Next slide.
So in our blockchain module of a system, so what happens is in our system, we implemented a lightweight private Ethereum blockchain using local development network. So the blockchain layer consists of a Solidity smart contract, a Python backend interface, and an event-driven invocation from the anomaly detection and prediction modules. So this keeps the blockchain interaction off the sensor data path, thereby ensuring low latency and real-time operation. A Solidity smart contract was deployed using Remix IDE and records only the safety critical events, thereby ensuring the low latency and scalability. And each event is logged as an immutable blockchain transaction containing the sensor ID, event type, write phase, and timestamp. This provides round repeatable and auditable records and eliminates single points of trust present in centralized logging systems, and also provides strong guarantees of integrity, transparency, and accountability, which are all essential for post-incident analysis and regulatory compliance in aviation systems. So these are the results observed in our consensus regarding blockchain smart contracts. Now moving on to our results. So after finishing the model 1 of a project, we successfully managed to simulate working of 10 healthy aircraft sensors. So the healthy values were being realistically generated in all 3 phases and are being displayed. So we also integrated UI UX successfully, and which also included the graph view. And we observed the following on our web browser. After finishing the fault injection module of a project, we managed to simulate the degradation as well as the consequent complete failure of the aircraft sensors. So the faulty values are being realistically generated in all phases, and this was evidently observed in the graphs. And for our reactive anomaly detection, so we saw that we were able to
Sorry to
identify.
interrupt. This is a gentle reminder that you have 1 to 2 minutes to conclude your presentation.
Okay, yeah, thank you. So we managed to identify the failed aircraft sensor in real time, and we observed the following. And with self-healing, we saw that upon completing the self-healing, our project successfully managed to heal the identified aircraft sensor in real time, and the redundant sensors were visible in our logs, and values of the healthy readings are being generated by these redundant sensors. However, the graph showed 1 second gap, which was taken by the anomaly detector to identify and trigger self-healing. And there was no readings that were recorded in this gap. However, if you see the graph which was being shown by the proactive layer, the redundant sensor was starting before the complete failure of the sensor, and therefore the healing was triggered before the complete failure of the sensor. And as for blockchain, the ganache showed blocks being successfully created and added to the blockchain during fault detection, prediction, as well as self-healing triggered, and whenever a backup sensor was activated as well.
To conclude, this study is going to respond directly to main limitations that is noted in the current literature survey. Next slide. Unlike existing approaches that treat prediction, recovery, and transparency as separate components, our system integrates all 3 into a single scalable architecture. It can proactively detect the sensor degradation, switch to redundant sensors without data loss, and maintain a tamper-proof audit trail of all events. So as our future work, we plan to strengthen the cybersecurity by adding role-based access control, multi-signature authentication, and formal verification of smart contracts to ensure compliance with aviation safety standards. Thank you. These are our references. Oh, next slide. Yeah, thank you.
Yeah, the topic is too good blockchain enabled self-healing IoT framework. There are some basic questions. How can you provide the traceability through the blockchain?
Sorry, so could you please repeat?
There are some features of the blockchain technology.
Yes, sir.
One of the features is traceability.
Traceability.
Oh, yeah, traceability, yes, sir.
How can you provide it?
How can we provide traceability using blockchain?
Yeah.
All the events that were occurred were being logged as hashes and we can observe the hashes in Ganache. So say we want to move, trace back an incident using a timestamp or everything, all the timestamp was all the data that was included while forming the hash that was used to store in the blockchain. So to trace back an incident, we can simply go back into the Ganache or wherever we have logged, looking into the timestamp of when a block is being created and loaded, and see all the consequent blocks that were formed right before it or after it, which shows either a sensor was failed or predicted to fail, and also the consequent failure of the sensor. And also we can see the timestamp of when a block is being created and loaded, and see all the consequent blocks that were formed right before it or after it, which shows either a sensor was failed or predicted to fail. And and right after which the sensor backup sensor was started. So since it's blockchain, we can no way tamper these records that were being logged, and we can see the incident as it happens as a record consequently being displayed in Ganache.
Yeah, fine.
Thank you, sir.
Thank you, sir.
Thank you. We'll now move further. Our next presenter is Arul Nath, and the paper title is Connecting Practice and Technology Enabled Agriculture, a comprehensive review of AI, IoT, and emerging technologies for agriculture 5.0.
Good morning. Am I audible?
Yes, sir, you are.
Yes. Okay. So good morning, respected chair and participants. I'm Dr. P. Arulanand from Konkan Engineering College, Erode, Tamil Nadu. So today I'll be presenting a review paper titled Connecting Practice and Technology, a comprehensive review of AI, IoT, and emerging technologies for Agriculture 5.0. 2021 and 2025 to understand how intelligent technologies are shaping sustainable and climate resilient agriculture. Is my slides are visible, ma'am?
Yes, sir.
Okay. So I'm just moving on to the research gap first. So although AI, IoT, and 5G are widely discussed in agriculture, so their real-world integration remains limited. So our review identifies 5 key gaps. So first one is fragmented integration of AI, IoT, and connected technologies. And the second is uneven global research distribution with India leading, but many regions underrepresented. And the next one is poor interoperability among devices, platforms, and data systems. And the next one is minimal focus on ethical data governance. And the last one is limited attention to smallholder um, farmer adoption. So these gaps clearly indicate the need for inclusive, scalable, and multidisciplinary frameworks. So coming back to this introduction part of our paper, so Agriculture 5.0 represents the evolution of from basic digitization to autonomous, predictive, and sustainable farming systems. So technologies such as AI, IoT, and 5G sensors and edge computing enable real-time decision-making in areas like irrigation, crop monitoring, and farm machinery coordination. So unlike earlier models, Agriculture 5.0 emphasizes not only productivity, but also a climate resilience, sustainability, and farmer well-being. So this review focuses on understanding these technological synergies and their broader socio-technical implications. So coming back to our literature review, so the literature highlights AI and IoT as key enablers of precision agriculture. So machine learning models are widely used for crop stress detection, yield prediction, and resource optimization. So IoT sensors enable continuous monitoring of soil moisture, weather, and crop health. So recent studies increasingly focus on big data analytics, explainable AI, and sustainability integration. So, however, the literature also reports persistent challenges such as data heterogeneity, high implementation costs, complex modeling approaches, ethical and transparency concerns. So, hence, future research emphasizes ensemble learning, integration, multimodal data integration, and governance framework. So coming back to our methodology, so we adopted a structure review of literature methodology, peer-reviewed journal articles, conference papers, and book chapters published between 2021 to 2025. So were collected from databases such as IEEE, Elsevier, Springer, MDPI, and Wiley. Only studies focusing on AI, IoT, and emerging technology-enabled agriculture were included. So the selected articles were thematically organized to identify research trends, challenges, and future directions. So future directions are as per our paper, our analysis shows that future agricultural systems must be scalable, affordable, and sustainability oriented. And technologies such as edge computing, digital twins, and federated learning so can significantly enhance real-time decision making while ensuring privacy. Importantly, farmer-centric adoption supported by policy frameworks and digital literacy initiatives is critical to bridge gap between innovation and uh, practice. Once again, I missed the slides. So I'm coming to the challenges. Sorry for the delay. So despite technological progress, several challenges limit real-world impact. So the key challenges include lack of interoperability among devices and platforms, and connectivity limitations in rural and edge environments, high deployment and maintenance costs, low digital literacy among smallholder farmers. Additionally, data privacy and cyber security risks and the high energy consumption of AI models raise sustainability concerns. So these challenges indicate that technology solutions alone are insufficient without policy alignment and government support. So that we conclude, in conclusion, smart farming integrates AI, IoT, and data analytics to enable sustainable and resilient agriculture. So while global research momentum is increasing, practical deployment still lags behind. So addressing this requires interdisciplinary collaboration, ethical and human-centered AI, pro-farmer and climate-responsive approaches. So the success of Agriculture 5.0 ultimately depends on how effectively we translate technological innovation into a meaningful field-level impact. So thank you. Thank you for your kind attention. Thank you. Ma'am, am I audible?
Yes, sir. Thank you. Thank you, sir, for your presentation.
Thank you, ma'am.
We'll move further now. Our next presentation is with the author Nirali Patel, and the paper title is Enhancing Cloud Cybersecurity with Scalable Machine Learning Models for DDoS Detection. Hello. Yes, ma'am, you're audible.
Okay. Good morning, everyone. My name is Nirali Patel, and I am going to present my research paper titled Enhancing Cloud Cybersecurity with Scalable Machine Learning Models for DDoS Detection with my co-author, Akanksha Jain. Abstraction. We all know that India is going to be digitalized, right? Cybersecurity threats is also increasing. Traditional cybersecurity methods are no longer sufficient to detect modern cybersecurity attacks. In this research, we propose an intelligent detection approach using machine learning techniques. Our experimental results show that the system improves both accuracy and efficiency in detecting attacks. Introduction of my research paper. The cyber attacks today are becoming more frequent and complex. Manual monitoring of network traffic is not effective anymore. Because of this, automation detection system are required. Machine learning helps in analyzing large amount of data and detecting the threats. This research mainly focus on improving attacks detection performance in cloud environment. Now moving on problem statement. Existing system is generates a high false positive alerts. Signature based detection system fails to detect unknown traffics on cloud or in network too. Real traffic detection is difficult to high network traffic. Large network data increasing processing overheads and no need. We have no accurate solution, and we are providing that. What is the objective? The objective of the research paper is to design an efficient attack detection framework, improve detection accuracy, false positive rates, and traffic effectively, handle traffic or analyze traffic effectively, and analyzing real-time detection capability. What's the literature review? Traditional idea system are mainly rule-based or signature-based. They can't detect zero-day vulnerabilities. Machine learning model provides a better capability to detect them. Okay. Our proposed methodology is we collecting the data from cloud or HTTP traffic we are collecting. Then data is processed and cleaned. After that, important features are extracted from the traffic data, and machine learning model will configure out them. And finally, the system performs attack detection and classification. What is the system architecture? In this architecture, network traffic is taken and as input. The feature extraction module proposes the raw data. The machine learning model analyzes the extracted features. The detection and engaging the classifications and traffic and normal or malicious. Traffic is normal or malicious, which is configured by DDoS attack. Is that DDoS attack or not? That will configure that. This is a cloud instance we are created by AWS EC2 instance. One is the targeted and one is the monitor. Targeted we have generally we have 3 instance, but here one, and monitor is the one instance. Through target we are generating a traffic, and monitor EC2 will monitor that DDoS traffics. This is the pattern. ये सीपी यूटिलाइजेशन है, नेटवर्क ट्रैफिक कितने नेटवर्क में आ रहा है, पैकेट्स और कितने जा रहे हैं, एक्सेस लॉग्स, we can block them, or ये result. We are generally using the AWS SNS notification for CPU utilization. If there is high utilization, they will give us an email so that we can stop our instance or we prevent our system. Geolocation of suspicious IP address. This is a conclusion. The proposed system effectively detects attacks, and machine learning improves detection accuracy. False alarm are reduced and compared to traditional system. The system is suitable for real-time cloud environments and enhance overall network security. What is the future scope of our project? In the future, the system can be extended by deep learning techniques deploying it in real world networks, also in cloud and IoT environments, and continuous learning for new tech patterns. Thank you.
Thank you, ma'am.
Am I audible?
Yes, you are.
Okay.
Thank you for the presentation, ma'am. We'll now move further. Our next paper is being presented by Aishwarya Ranjan KK, and the title of their paper is Hierarchical Community and Sentiment Aware Network for Enhanced Social Media User Profiling and Analysis.
Hello, ma'am.
Yes, ma'am, you're audible.
Is my screen is visible?
Yes.
Can I start? Okay. My name is Aishwarya Rajan, and I am a research scholar of Cerebral School of Engineering. My research focus on social network analysis. Today, the title
Ma'am, you're not audible.
is it audible?
Yes, now it is.
My topic is hierarchical community and sentiment aware network for enhanced social media user profiling and analysis. Here we know that social media plays a major role during disasters and emergencies, but existing community detection and sentiment analysis method mostly focus only on either structure or emotions. This creates an incomplete understanding of user behavior. To solve this, the hierarchical community and sentiment aware network framework is proposed. It integrates hierarchical community detection with sentiment aware user profiling using weighted interactions and transformer embeddings. These are some of the recent research in community detection and sentiment analysis that I go through. From this, I identified that existing tools fail to fully capture both the structural and emotional dynamics of user interactions. Most current methods focus on either on network structure or sentiments, not both together. Traditional algorithms do not consider sentiment-weighted relationship, resulting in incomplete and or inaccurate community identification. Lack of hierarchical community modeling limits fine-grained understanding of subgroup behavior and influence patterns. Also, the absence of integrated sensitive user profiling hinders accurate behavioral analysis and influence quantification. From this, my research objectives to I develop a hierarchical community and sentiment aware network model for social media analysis. Also to integrate hierarchical community detection with sentiment aware profiling. To design a sentiment weighted modularity to generate sentiment sensitive user embeddings using transformer based representation and normalized attention. Also to identify fine grained sentiment patterns within and across communities thereby to improve accuracy, precision, recall, and sentiment agreements for to enable a better influence qualification and behavioral analysis. When I move into the research methodology, HCSAN is a framework designed to analyze both the structure of social media connections and the emotions expressed by the users at the same time. So HCSAN treats social media users as nodes in the network, and the connection between them becomes the links or edges. These links are given a weight based on two things. First one is how often the users interact. Second is how similar their feelings are in their post. And this is my architecture. In this architecture, first one is data collection. Here we collect user generated contents, that is use the emotions or replace from the users are collect. Then second is pre-processing. In pre-processing, we clean text and represent user interactions as weighted edges. The next step is weighted graph construction. Here create a heterogeneous social graph where user are nodes and sentiment similarity. Then next step is sentiment extraction. We use a transformer model to generate fine-grained sentiment vectors for each user's text. Then is edge weighting. It combines interaction frequency and both sentiment similarity to compute the relationships to identify the levels, that is to identify macro, sub and micro communities. Then next step is graph and sentiment fusion. It uses an attention mechanism to merge graph embeddings and sentiment embeddings into sentiment effect. Next step is community sentiment profile. It aggregates user sentiments to compute an overall community sentiment vectors. Then last is analysis of output. Here is my algorithm. Here the inputs are user data, that is post comments interactions from the users. Then parameters being edge weighting, sentiment modularity weights like that. Transformer model for sentiment embeddings. Here example is a BERT, bidirectional encoder representation. Then graphical neural network for graph embeddings. Then steps is first step is I already did that it is a data pre-processing step, collect user interactions and textual content. Then next is the clean and normalize the data and represent users as nodes and interactions as edges. Then second step is a construct a weighted social graph. For each pair of users I and j, Fij means it is an interaction frequency between node I and j. Count how many times the users interacted. Si and Sj means sentiment vectors of I and j. Initially, it is empty and placeholder sentiment vectors. Sij is sentiment similarity between nodes I and j. It measures how similar their sentiments are. Wij is the weight. Actually, it is a weight. Final edge weight is combined combination of how often they interact and how similar their sentiments are. Then last, we add the edges with the weight, build a weighted social graph. Next is hierarchical community detection. In hierarchical community detection, initially communities, all nodes are singleton. Every node has its own community. Then repeat until modularity converges. Continue grouping users until no further improvement is possible. Then we compute the is. Here first term measures structural modularity based on edge weight. Second, the gamma parts incorporate sentiment similarity. Then delta of Ci, Cj equal to 1 if users I and j are in the same community. Then merge nodes or community to maximize this QS. The communities are merged if it increases the modularity score. Then output the hierarchical communities in macro, sub, and micro. That is in a multi-level community organization. Then next is sentiment embedding for users. The TI means textual content of user I. It collects all posts and comments from users. SI means transformer use bird or similar transformers to extract a sentiment vector of dimension D. Then next is graph embedding. Apply graph neural network on G to compute graph embeddings. The GNN learns each user's structural role in the graph. Next, attention-based fusion. It combines graph embeddings and sentiment embedding using weighted linear layers, attention mechanism, and also by using activation function. The result is a sentiment-aware profile. Then next is community level sentiments. It averages sentiment vectors of users.
Sorry to interrupt, ma'am. This is a gentle reminder that you have 1 to 2 minutes to kindly conclude your presentation.
Okay, ma'am. This is my result. Here, HCN is more effective than convolutional approaches in terms of accuracy, precision, and recall, and similarity of sentiments. These are my result. It shows best precision in cluster identification. Also have high recall and all among tested. This is my conclusion. It HCN integrates structural relationship and sentiment analysis in a single framework. Also uses hierarchical community detection, transformer attention mechanism. it outperforms the previous algorithms and enables more accurate community identification. These are my references, and thank you. Hello, ma'am. Is it audible?
Yes, ma'am. Thank you. And moving further with our next presentation. Uh, we have author Rakesh More with the paper title Human AI Collaboration in Commercial Underwriting, a controlled evaluation of AI workbenches.
അവരോട് ചോദിച്ചിട്ടില്ല. ആദ്യത്തെ ഒന്ന് രണ്ടാളോട് ഒരുത്തനോട് മറ്റേ
Is my screen visible?
Yes, sir, it is visible.
Okay, just give me 1 minute. Okay, thank you for the confirmation. Good morning and welcome to our presentation at the 10th International Conference on Information and Communication Technology for Competitive Strategy. Today, myself, Rakesh More, along with my two co-authors, Sudarshan Verma and Nilay Verma, we are going to present our study on human AI collaboration in commercial underwriting, a control evaluation of AI workbenches. And so our study examine how AI workbenches are transforming commercial insurance underwriting through a rigorous control evaluation. So let's discuss about it. So before uh, I discuss about the my research motivation, I'll give you the little bit background. So those who are new to insurance jargon, so uh, AI, like AI workbench in insurance, is a digital platform where the uh, this underwriter is a person, or particularly we can say that the role, they calculate the risk for the client for the particular uh, company. So how risky this client is, that particular, so that is their job, that is called the underwriter. And this they'll use the AI workbench, that is a digital platform which is having the complete workflow to calculate the risk. And when we talk about the commercial insurance is a very big thing, and the uh, underwriter role is a very, very critical in that one. And commercial insurance right now facing some challenges, like those challenges we have pointed here, like 5 point pain points. And as per the research, 86% of underwriters spend greater than 2 hours per day on manual data entry, and that is the, we can say that, the low administrative task. And then additional challenges are unstructured data sources, inconsistent risk assessment, and then the increasing regulatory uh, compliance demand. So these are the motivation to do this study, where we are thinking AI augmentation is necessary to enhance the underwriting process rather than replacing the underwriter. And our study also addresses the knowledge gap, uh, like the measurement of AI ROI, quality matrices, and the balancing human and AI combinations. And those who are already using AI workbenches, as per the study, there is a 31% improvement in the processing time, and then the complex policies, the speed is also increased, which is used to take days. Now it is taking minutes. So let's move to the next is, so our study is based on the four key components. Like first is the automated pre-fill capabilities. that enables the both internal and the external data sources to populate the application data automatically so that we can avoid the manual entry. Second is the predictive models that analyze the risk factor and recommends pricing and coverage term. Third is the remote survey technology uses AI powered images analysis for virtual property inspection so that don't enter so that underwriter don't have to go to the particular place to do the remote survey. And then the last one is that the finally collaboration layer that enables the real-time communication between the underwriter, broker, and the client to make a decision. And then the main key point here is that we want to integrate this component, uh, and we want to utilize the underwriter expertise without replacing them, so that those underwriter can give more attention to high value and the complex task rather than just entering the data manually or just calculating using the Excel sheet. So our theoretical complete study is based on the three theoretical framework. The first one is that the technology acceptance model, where uh, we understand or which help us to understand, pursue and adopt of AI workbench tool, how they are useful for underwriter. Second is cognitive load theory, how the AI impact mental processing so that we can reduce the cognitive load from the underwriter and allow them to give some more time to do the complex task. And the third one is the organization learning theory, how knowledge is captured, distributed, and used with the help of human and AI collaboration. So when we integrate all these three framework, that time we'll get a better understanding of human and AI collaboration. Our research hypothesis, which is based on the four hypotheses, which is coming from our this theoretical framework. The first one is the efficiency hypothesis, that is the AI workbenches will significantly reduce processing time while maintaining comparable decision accuracy. We just discussed cognitive load hypothesis, like underwriter using AI workbenches will experience reduce cognitive load so that use their they can use their time or focus on the complex risk model. Adaptive hypothesis, like pursued usefulness will be stronger, like the main usefulness is important whether it's complex or easy. Instead of easy task, if the more accurate task is given to the underwriter, that will be more useful. Then the learning curve hypothesis, like how organization. So here the simple theory: if the organization using the double loop learning, there is a chances of they will the return or ROI will be more from them. Those who are limited are using the single loop. Single loop learning is a simple thing where we are using how, and then the double loop learning is that where we are using why to calculate the what happened or what was the mistake. And we tested this thing by using the mix method, like the combination of quantitative productive matrix and then the qualitative user experience in control field experiment. So here is the our methodology or experiment what we did here. And before we move forward, I want to make one disclaimer, due to proprietary nature, the commercial underwriting data, this study, what we are employed, that is the synthetic data. Sorry. There is a synthetic data. This is not the real world data. We have taken the data from the open source. So we are proposing methodology in the three phases, distinct phases, that is baseline phase, intervention phase, and follow phase. That is the 3 months, 6 months, and 3 months, and proposing to collect the data baseline along with the 1, 3, and 6 month checkpoint and the final assessment. So we have did this study with 120 underwriters, 4 insurance carrier, and 24 policy submissions. and our results are very promising. As I said, we are using the synthetic data. That's why, as a baseline, we have used the external benchmark, which are available in the market with the help of some research firm. And our finding is showing that reduce manual data entry by 62%, decrease review cycle by 3.2 to 1.4, and improve throughput capacity by 41%. So here you will see the operational efficiency that is the cycle time is reduced by 47%. And if you may be wondering why it is market research is 31% and we are more than 60%, it is because we are proposing the AI and human collaboration. When we do the AI and human collaboration, definitely will get a better result. Those who are only using the AI. This is the another matrix, that is the decision quality and consistency, where we are seeing the very good result. Here also we are using the external benchmark from the market, but our results are showing promising results with the increase in the 28% accuracy. And all those results are validated by the expert from the industry experts, basically.
Sorry to interrupt,
Uh,
sir. You have, this is a gentle reminder that you have 1 to 2 minutes to conclude the presentation.
Thank you, ma'am. Yeah, and I'm concluding. So, as our research or study title was to human AI collaboration, and this is the our collaboration principle we are suggesting for the optimal human AI collaboration. So for the complementary strength, we are suggesting that AI should handle the repetitive tasks like the data entry, data collection or data entry, standard risk classification, standard pricing, or documentation, while the human should manage the judgment intensive decision like complex risk assessment, negotiation exceptions, and then the final approval. And there should be clear accountability for human should do the final decision authority. And with that one, we should do the continuous learning, because of human, we based on the human feedback we can adjust the AI output where we'll get a better results. So this is the main thing of our study. To conclude, based on our finding and the study, we are seeing that transformative efficiency, where we are seeing the AI workbenches dramatically reduce the processing time. Complementary strength, we just discussed that the optimal human and AI collaboration with allocated responsibly based on the comparative advantages. And the organizational learning, like how those who are using the double loop, they are seeing the more or higher ROI. So to conclude a complete study, I would say the future of commercial underwriting lies not in the AI replacing human underwriter, but in redefining the underwriter role to focus on where human expertise add the most value. And this is the main message we would like to give. Based on that, I'll conclude my presentation. Thank you for your time. If you have any question, we can discuss.
Wonderful session by Rakesh. Thank you. Thank you
Thank you,
very
sir.
much.
Thank you. Yeah.
Thank you, sir. Now we'll move further. The next presentation is by the author Kuadan with the paper title Knowledge Sharing as a Pathway Linking Workplace, Spirituality, and Innovative Work Behavior. Sir, you are not audible. Kindly please unmute yourself.
Okay, yes, good morning, all scholars, ladies and gentlemen. Yes, today's my professors, as I honors yet to take back into yes the ICTCS 2025. Okay, and yes, we will present yes about our papers. Okay, yes, please wait for a minute. Okay, uh, today's yes, we will present yes about yes our papers yes knowledge sharing as a pathway linking workplace spirituality and innovative work behaviors. And okay, this is one of the research yes on the organizational behaviors. This is the agendas yes and yes I will present yes about yes my papers our paper sorry. Okay, in recent years, okay, yes, workplace spirituality yes has received yes growing attention to in organizations no behaviors research. Okay, the scholars yes increasingly yes emphasize that employees are not only motivated by intrinsic reward, but also by their desire to find the meanings in their work, building generous connection, and align their personal values with those of organization. As the original yes conceptualized by the Asmos and Durham yes 2000s. And okay, at the same time, okay, the knowledge sharing has long just been recognized as a critical process through which individual idea are transformed into organizational innovation. And prior studies suggest that yes, one yes, employees actively yes exchange knowledge. Yes, they are more likely to generate, yes, refine and implement in new idea. And from this perspective, yes, knowledge sharing yes may serve as an important yes mechanism linking workplace spirituality yes to innovative behaviors. And the empirical yes investigation of this mediating pathways yes remains scarce, especially yes in the logistics yes industry. So by addressing this research gap, yes, and we can and yes, we and this study yes aim to examine it, yes how workplace spirituality yes influence employees yes innovative work behaviors. Yes, with particular yes, attention to the mediating roles of the knowledge sharing in the context of Vietnam logistics sectors. Okay, next in literature's review. Okay. First, yes, I will yes introduce about the workplace spirituality, the definition of the workplace spirituality. The workplace spirituality just reflect yes employees yes pursuit of the meaningful inner fulfillment and alignments between the personal and organization values. Okay. And yes, the knowledge sharing, yes, is widely recognized at the core, yes, organizational process that sustain the competitive advantages. Is it involves the voluntary exchange and implication of both taxes and implicit, yes, knowledge, yes, among the employees. And finally, yes, innovative work behaviors is conceptualized as a multi-dimensional and ongoing behaviors. It's encompassed yes, from the idea generation, idea promotion, and idea implementation. Okay, next, in these papers, okay, we apply, yes, we apply just the the person organization fit theory. Uh, According to yes, person, yes, organization fit theory, yes, okay, yes, argue that this theory argue that yes, the employees' attitudes and their behaviors are strongly influenced by the compatibility between individual values and organizational yes characteristics. And one employees they perceive a high level of value concurrent. Yes, they are more likely to experience psychological comfort, the strongly identification yes with the organization and higher intrinsic motivation. And yes, we apply yes the person organization fit theory yes to describe yes all of the hypotheses and and yes build up yes the model. And we can see that, yes, we propose, yes, 4 hypotheses. And yes, the first hypothesis is the workplace spiritualities, yes, positive belief influence knowledge sharing, yes, positive belief, yes, influence, yes, innovative work behaviors, workplace spirituality, positive influence, yes, innovative work behaviors, and the last one. Yes, the knowledge sharing, yes, mediate yes, the positive relationship between the workplace, spirituality, and yes, innovative work behavior. Okay, and in this research, yes, this research employs quantitative research design. Yes, for more details, the data are collected using the structured questionnaire which measurement scales adapted from the well-established prior study to ensure the content's validity and reliability. And the final data set is consists of 782 valid responses from the diverse workforce in the logistic sectors. And in this study, the workplace spirituality, were measures based on the scale development by millimeter, and that college. However, in our research, we have to build up a context, specific attention. And we name actually the perceptual sensitivity in organizational values. And this is the spectral aspect when we develop our research in Vietnamese sectors, in Vietnamese logistics sectors. Okay. And knowledge sharing, measures using the scout, proposed by Van Den Hoaf, and the writers. And the innovative work behaviors, were accessed using the scout developed by De Jong and the Hartog. And in the data analysis, we apply the SPSS and AMOS, to analyze our data. Okay. To solve outcomes. Okay, I will show to all of the authors that apply into this section. All of the result. From the data analysis. Okay, reliable analysis result. Okay, it is exploratory factors analysis result. Retraction rate and factors lodging for measurement items. Convergent and discriminant validity, and the last one, the hypothesis testing. And all of the direct hypotheses are strongly supported. And as you can see, all of the result on the slide. And the knowledge sharing, they partially mediate that relationship between the workplace spirituality and the innovative work behaviors. And according to all of the result, we conclude. Okay, we mentioned several key findings. First of all, okay. The result show that the workplace spirituality strongly predict knowledge sharing. Okay, And the sustainable effect side just indicate that when employees experience meaningful work, a sense of belongingness and the alignments between their person and the organizational value. They are more willing to engage in trust-based and pro-social knowledge exchange. That means, they have to exchange the knowledge sharing the knowledge within an organization in voluntary. Okay. And second, the finding also demonstrate that knowledge sharing significantly in innovative work behaviors. This result reinforced prior research suggesting that innovation is not solely on the individual cognitive activity, but also is the social process, the process. Okay, that means they can be affected by the alignment between the person and their social and in this sense, the knowledge sharing function as a critical mechanism employed in playing IT generation, refinement and implementation is the three sub process of the innovative work behaviors. Third, the workplace spirituality also found that to directly promote innovative work behaviors. This suggests that spiritual related to the meaningfulness and the intrinsic motivation of the employees can independently stimulate employee willingness to engage in innovation oriented behaviors that go beyond the formal job requirement. Okay, and importantly, the mediation analysis revealed that the knowledge sharing partially mediate the relationship between the workplace spirituality and innovative work behaviors. Okay, and this finding meet to the objective so that's a research gap when we mention on the first line, and this finding
Sir, Sir, I'm sorry to interrupt. This is a gentle reminder that you have 1 to 2 minutes to conclude the presentation.
Okay, thank you very much. I will
Thank you, sir.
Move on to the conclusion on 2 minutes. Thank you, ma'am. Okay, as this finding clarifies the underlying mechanism through which workplace spirituality translate into innovation, while also indicating that its influence is both directly and indirectly. And the last one, okay, from the theoretical perspective, this study extends person organization fit theory, by showing how value alignment and meaningful work translates into into innovative work behavior through the knowledge sharing process. And from the practical perspective, the findings suggest that fostering workplace spirituality can serve a strategic level to strengthen knowledge flow and employees innovation. Particularly in the knowledge intensive and coordination dependent sectors such as Vietnam logistics sectors. And the conclusion. This study showed the workplace spirituality promotes innovative work behaviors both directly and indirectly via knowledge sharing. Highlight is the dual psychological and relational growth in thriving employees innovation within an organization, especially in the developing country sectors. Okay, And that's all for our presentation, the papers. Okay, yes. Thanks for listening. And any questions? Yes, for our papers. Okay.
Thank you, sir, for a wonderful session delivered by you.
Okay, yeah. Thank you, professors. Thank you very much.
Thank you, sir. Now we'll be moving further.
Okay, thank you, ma'am.
Now we have the paper by author Samuel John with their paper title AI powered brain tumor segmentation and treatment recommendation system using Mark RCNN and Gemini model integration.
Good morning, ma'am. I'm audible.
Yes, sir, you are.
Good morning to everyone present here. I'm Samuel John, and I'm honored to present our research on AI-powered brain tumor segmentation and treatment recommendation system. Today, I'll be demonstrating how we are bridging the gap between medical imaging and clinical reasoning. Let's move on to the introduction. The challenge we address is critical. Brain tumors pose a major diagnostic difficulty. Doctors face a very hard time by diagnosing the brain tumors. Even though MRI is the gold standard, the traditional manual reviewing process is subjective and time consuming. This often leads to inconsistent tumor boundary detection, which can critically impact surgical planning. Our goal was to build an AI solution that not only segments tumors, but integrates clinical data for actionable decisions. Let's move on to the problem statement. We have identified three core problems in our current workflow. First, inconsistent detection. Manual analysis lacked the precision needed for identifying specific subregions. Brain has many subregions which needed to be identified very carefully. Doctors failed to do so in some scenarios. Data silos. Current systems fail to combine imaging data with patients' clinical history. Now, and lack of reliability. Without relational reasoning, AI tools often fail to match clinical guidelines across diverse patient profiles. Now we move on to the methodology and architecture. So here we have the proposed system overview. So I'll give an overview of our project here. So to solve this, we have developed a three-tier system architecture. First, segmentation. For segmentation, we have used mask RCNN. This has higher accuracy level and instant level detection. Instant level detection is a very important thing in brain tumor segmentation, since brain has very minute parts which should be detected at instant level. Second, for recommendation, we have used Gemini large model LLM to interpret both images and the text. We get the input from the the first process, which is the segmentation process, and then we get the the patient details and etc. from the second process, and then we provide the recommendation, the treatment recommendation in the third process. And for even more powering the recommendation, we have used graph neural networks, GNN. Now, data acquisition and pre-processing. Our pipeline is very robust. We need multi-parametric MRI sequences, specifically T1, T2, and FLAR, to capture comprehensive human data. T1 highlights that anatomy, while T2 and FLAR are crucial for detecting edema. We process these through a pipeline, including skull crippling and Z-score normalization to ensure model stability. This is the tumor segmentation part, the first part of the project. For this, we have used the mask RCNN engine. First, we used a unit, which was the commonly used segmentation engine, but it didn't support semantic models. But RCNN provided instant level clarity. This is vital because it allows us to separate distinct subregions, which is critical for surgery, such as enhancing core, necrotic core, and the peritoneal edema. The region proposal network ensures we preserve boundary precision. Now I'll show the performance benchmark of mask RCNN. We validated this choice against standard architecture. As you can see here, mask RCNN has a superior dice score of 0.91. This significantly outperforms UNET. which is commonly used, at 0.75, and Deep Medic at 0.81, proving that our approaches can offer higher clarity than traditional models. Feature extraction and fusion. However, accurate segmentation is only half of the battle. Our system performs feature fusion. We extract quantitative features from the MRI, such as tumor volume, intensity patterns, simultaneously. We process unstructured clinical data on the other side, such as pathological notes, radiology reports, etc. Using the Gemini LLM, this fusion allows for evidence-based reasoning. Now, it's the treatment recommendation part. Here we have used Gemini LLM. This system merges image-derived signals with textual records. The key capability here is the alignment. Our system outputs ranked treatment optionals that align directly with the NCCN clinical guidelines, drastically reducing planning time for the neuro-oncologists. Now, GNN contextual reasoning. Even for further improvisation, we have used graph neural networks. In our graph, nodes represent tumors, regions, and patient traits, while edges encode the spatial and semantic relationship. This allows the system to learn from similar historic cases, improving personalization. And this is the ablation study. Here we can, excuse me. Here, mask and Gemini alone gives us just mask gives us 0.85% precision, whereas including Gemini, we get 0.93 precision. And with the full system, including GNN, we reach 95% precision. This confirms that contextual reasoning is essential for higher accuracy. And the result summary. To summarize our technical results, we achieved the DICE score of 0.91 for segmentation and recommendation of precision of 0.95. Perhaps most important for clinical deployment. This inference time is approximately 12 seconds, making it feasible for real-time use. And this is the application interface where we have deployed this model into a user-friendly web interface designed for interoperability. It features a secure role-based login and simple 3-step workflow, secure access, one-click MRI upload, and instant visual insights. We just need to input various data such as our name, password, age range, gender, etc. And now the clinical impact. Patient safety. It reduces misdiagnosis such as various excuse me, through automated checks and 3D visualization. And efficiency. It's drastically reduces the manual workload for radiologists, while the GNN-based reasoning provides clear evidence pathways to enhance trust. Conclusion and future scope. In conclusion, this system successfully bridges the gap between the imaging and the reasoning. It's scalable modular design, paving way for precise neuro-oncology. Looking ahead, we plan to introduce multimodal fusion with PET and CT scans and real-time EMR integration. This model just integrates MRI scans, and we further need to improve it. Thank you for your attention, and now I'm open for any questions. Thank you.
Thank you
Thank
very
you.
much for such wonderful talk.
Okay, thank you, sir.
Now we'll move further. We have author Dhaneshwar Natha Vavhal with the paper title Data Driven Prediction Framework for Best Match Donor Selection and Survival Estimation in Liver Transplantation.
Yeah, thank you, ma'am. Is my screen is visible to all of you?
Yes, sir.
Uh, Good morning, respected panel members. My name is Naneshwar Nathawal, and today I am going to present our research paper entitled Data-Driven Prediction Framework for Best Matched Donor Selection and Survivor Estimation in Liver Transplantation. This work proposes a novel hybrid machine learning framework that is called as an liver matchnet designed to improve donor recipient matching as well as pre-transplant survival prediction in liver transplantation. So these are the outlines of my presentations. First of all, introduction. Uh, so liver transplantation, it is a critical procedure for the patient with end-stage liver disease. As you know that in liver transplantation is nothing but the replacement of non-functioning liver. Means whatever liver it is get failure or disease liver with healthy liver from another person. Liver transplantation is the treatment option for the end-stage liver disease, and the person who is suffering for acute liver failure, so for that persons they are suggesting the liver transplantation. So although the availability of donor organ is a major challenges over here in liver transplantation, so most common techniques nowadays doctors are using, in which native liver is removed from donor and replaced by the donor organs in the same anatomical positions in the original liver. The surgical procedure is too much complex and requiring careful harvesting of our donor organ, and the duration of surgery it is taking 6 to 18 hours. So it's depending upon the outcomes. So there are various risks while transferring liver transplantation. The liver rejection after transplantation. In order to avoid such kind of rejections, so I am going to develop this system. So what it can do, it can save lives, but its success heavily depends on compatibility in between the donor and recipient. Actually, existing method for matching donors and recipient often lack of predictability. So data used in the current methods, it can be easily distorted, leading and suboptimal matches outcomes. So what it does, it enhances predictive accuracy using advanced machine learning techniques. So uh, actually, this liver transplantation, it is most effective treatment for the end stage liver disease and acute liver failure, as I suggested. However, the availability of donor organ is extremely limited, and making optimal donor allocation is a critical clinical challenges over here. So currently, organ allocation decisions is totally rely on the MELD score, that is called as an model of end stage liver disease, and for children's child purge score. In MELD score, if the person whose MELD score is greater than 50, so there is the chance that after liver transplantation that person it will sustain long life. But if MELD score is less than 50, then the survival rate is less. So while these systems are clinically useful, uh, the person or the patient who suffer for these three limitations. Very first one, it is first consider limited biochemical parameters. Second one, it is the person they do not have the any what you can say that complex donor recipient interaction. Then the fail to directly predict survival probability. As the results, matching can be lead to the graft failure, reduce survival and wastage of the donor. So this motivates the need of intelligent and data-driven decision support system that can jointly help to predict the survival probability, optimize donor recipient matching. So these are the some motivations, so I can do this research work. So this is the main aim of my research, to develop a robust recommendation framework that identifies the best match donor before liver transplantation for the patient who is suffering from end stage liver disease. So these are the objective of my research: to review and analyze the literature of existing models, thoroughly to collect data from different sources and implement attribute selection techniques for pre-processing, then to design and apply advanced multi-layer perceptron approach for achieving accurate and effective precision prediction survival before liver transplantation, and to implement the proposed system to predict survival before liver transplantation in the time among live as well as dead is estimated based on the poor or best survival rate. And finally, to validate the result for the framework for best matching donor before liver transplantation for the patient who is undergoing liver transplantation. So these are the some literature reviews that I have done and completed. So over here they are not using this kind of enhancement in the liver transplantation. So these are the identified gaps over here in literature review, and I tried to cover up all these identified gaps in my research. So, in recap of this previous work, we identified several factors that are important for selecting the best matched donor for liver transplantation. These factors includes blood type compatibility, age of the donor, medical history of the donor, liver function. Also, we explore different approaches for developing a recommendation framework, such as using weighted scoring system or machine learning model. So this is my proposed system architecture. So to address all the
Sir,
challenges,
sorry
yeah.
to interrupt. This is a gentle reminder for 1 to 2 minutes presentation conclusion.
Okay, okay, ma'am. So, we collected comprehensive donor and recipient data, including demographic features, clinical indicators, biochemical parameters, donor attributes. Thereafter, feature selection, we are using lassos. So, medical data sets are typically high dimensional and correlated. We are applying lasso regression in order to introduce L1 regulation penalties to eliminate redundant as well as irrelevant features, retain only clinically significant predictors. Thereafter, next stage, it is a multi-layer perceptron layer. To select selected features are fed into this multi-layer perceptron, which serves the core of a predictive engine. So liver transplantation outcome comes totally depends on non-linear interaction, and multi-layer perceptrons captures the complex hierarchical relationship in between linear models. So next one, it is liver likelihood estimations. So instead of giving only binary outcomes to the liver output probability of survival, which is totally based on the patient classified into the low risk or high risk group, and threshold based stratification it is get applied. Then donor recipient matching. So donor recipient matching, it is relies on clinically compatibility like predicted survival probability among all compatible donors. Liver matchnet selects the
Dear
donor.
presenter, you may please conclude your presentation.
Okay, these are the methodologies uh, that is get used in my proposed system. So these are the basic steps of the livers. So these are the algorithms I proposed, and finally result it comes. Uh, and I have taken the guidance from uh, these concerned doctors who are uh, in liver transplantation specialist. So in this way, the proposed liver matchnet framework presents an efficient hybrid approach to augmenting donor recipient matching and pre-transplant survival prediction in liver transplantation. Thank you very much. Any questions?
No, thank you.
Thank you, sir. Thank you, ma'am.
Thank you. With this, I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 10th version of and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their certificates through email within 2 working days. And The publication would be live in 7 to 8 months. Kindly cooperate with the team of ICTCS 2025. I also thank our session chair. Sir, thank you so much. And this is a token of appreciation.
Thank you.
Sir, if you would like to.
Thank you. Thank you very much.
Now, I would like all the participants and sir to kindly please turn on the camera. Just a minute. Thank you. Thank you, everyone.
Thank you.